Okay, so our screen is being recorded so that in future, if you want the video recording, most probably I also post it on YouTube. You can just go and look at it and see what things we're doing. So I come here, open with, and I have this particular option here, which is Google Collaboratory, which is what I'm going to use for these particular lectures. So you don't have to install any software. You just need the files themselves, and you put them on your Google Drive. As long as you've got a Gmail, you also have got access to Google Drive, then you can proceed from there. So with that, Google Colab will start opening. I'll share the other tab with Google Colab. And my file has opened. So basically this is what's in that particular file. So the title, as you can see, a quick introduction to Python 3 programming language. Our chapter 1 is just basically trying to introduce you to how you do certain things. And one of the things we're going to look at, which are important in this particular case, is how do you print numbers, how do you print strings. Strings are basically text. How do you print booleans? Booleans are true or false values. How do you perform simple mathematics in this particular case? How do you create comments? Comments are important to you in your programming because you want to give yourself some notes on what is it you're doing, and also other people, if they look at your code, they should be able to see what you're telling them what you're doing. How do you create variables? Without variables, it's very, very difficult to do any meaningful programming because we use variables to hold values. How do you ask for information from a user? In this case, we're going to do that. And also, one of the things about Python is that unlike other programming languages where when you create a variable, you have to state what kind of value is going to be in this particular variable. In Python, you don't have to do that. So you can just use the variable like that, but you're given a way of trying to find out what kind of data is in a particular variable, so you can see how to do that. And how do you do data conversion? We'll see this. Then we'll create a simple Python program which is going to work out the area of a circle, and we'll see by combining everything which we have learned today in that particular case. Then also, if we've got time, we're going to look at lists and tuples, which are a bit more complex. Lists because they allow us to store a lot more information, and that's basically where the whole thing starts. Now, for you to print anything in Python, those who are joining us online, can you see? Is our thing clear? Okay.
Yes.
All right. So for you to print anything in Python, basically, the Python comes with built-in. You don't have to do anything. This particular function is already there. It comes with the print function, which you use for this particular thing. Okay. So what you do with the name of the function is print. Then any particular function has got these parentheses after the name of the function. So in this particular case, if I want to print the number 100, and anyway, I forgot to do something. Since we are using a browser, we are using Google computers. So I need to connect to Google servers. So I click on connect there. They're going to allocate me computing space, and they're also going to create a Python environment for us to use. So basically, that's what they're doing, is connecting, is initializing. Then you see how much how much size of a virtual computer they would have assigned us. So there, we are now connected to the Google Python computers. So if you look here, you will see that we have access to, if you can see, you have access to 12 GB disk space to use. You also have access to, 12 GB, that's 12 GB RAM. And what am I looking at? About 107 gigabytes. So basically, if you have any simple computer, Google are going to give you a virtual computer which is very fast for you to do your computations for free, as long as you have a Google account. Yes, there it is. I didn't do anything. It's just that we have got a Google account, then we can do this. So with that, now we can start trying to do what we're trying to do. So if I want to print an integer, for example, the number 100, the only thing I do is I type out print, then inside these parentheses, I put the 100. Then there's this play icon here. If I press on that, then you can see that the 100 gets printed out. So basically that's how print works. You type your print, then in the parentheses you put the value you want to print, like that. You can also print values which have got decimal points. For example, like what you have there, 3.14, which is basically pi. So I can simply say print 3.14, then I click on that bit there, it prints it out, 3.14. Python also comes with a built-in ability to support complex numbers. So basically, in this particular case, I want to print out this complex number 5 plus 4j. So I'll just simply say print 5 plus 4j. Python understands this. The reason it understands this is because Python, baked inside Python, there is support for it to understand integers, for it to understand floats, for it to understand complex numbers, which might be interesting to someone who is doing physics or someone who is doing mathematics, because at some point you might have to do all these things. Apart from printing these numbers separately like the way we have done, it's also possible that you can just print them at once. So basically what I have here, this is what is referred to as a cell. So this bit here is the Python environment. I've got this tiny Python environments where I can run Python code. These other things here, this is just basically text. Me trying to give myself instructions of what is supposed to happen. And since this is basically a lesson, I'm giving instructions to whoever will be running this particular file, say this is what you're supposed to do. So basically, the whole thing is divided into bits of instructions and bits of Python environments where you run this code, then Python is going to understand what is it you're trying to do. So here, in one cell, we want to print 100, we want to print in the 3.14, we want to print the complex number 5 plus 4j. So I click on run there, you see that it prints out these things. So basically that is us running a bunch of lines in one cell. You can also do the same thing. Instead of stacking them vertically, you can try to put your codes horizontally, which is something I don't really encourage. But if you decide to go that way, then your Python codes, you have to separate them by semicolons. So this one, the first print will give us 100, the second print will give us 3.14, the other print will give us that complex number there. So if I run this here, we get the same thing. So basically, if you look at what you have, the output, in this particular case, the result, is indistinguishable from the other one, as much as we decided to arrange things differently. But this is much more readable, it's much more clear, so I encourage the use of this approach. Basically, your code's coming one after the other like that. The print function, so far we have used it to only print one value, but it allows you to print multiple values. As long as the values you're trying to print, you have separated them by commas. So inside the print function, here, I want to print the value 100. I also want to print 3.14. I also want to print this complex number. So I separate the values by commas. If I do this, I run it, and this is what I'm going to get. So I get all my results now on one line like that. Your print also allows you to print very, very large numbers. But if you're going to print very large numbers, which can be very cumbersome, then the use of scientific notation is encouraged. For example, the distance from Earth to our sun, which is basically about 150 billion meters in this particular case, so you've got a lot of zeros there. You can print this, you say print that thing there, and you're going to get that, it's going to print that. So your print function can also display very large numbers, but it's not very clear. So if you want your number to be a bit clear, you can separate in the thousands, you can separate your number by putting underscores there. This is just for you so that your number is a bit readable. So you can see that, okay, you're dealing with a very large number, but if you make a print of this number, the result is basically indistinguishable from that. But I would encourage the use of this because it's more readable. You can see where the the zeros are demarcating and you have a good idea of what that number is. Even better though is basically you have to type a lot of zeros here, but you can use scientific notation. This same number, when expressed in scientific notation, is this one, and you can simply print it like this. So basically, the margins are here. You type your margins, which is 1.496. Then the times 10, in this particular case, is represented by the E, then the exponent 11 like that. So if you do that, that's what you get. The only cost in this particular case is the additional dot and the zero you're going to get, but it saves you the trouble of typing so many zeros, which at the end of the day, you might make mistakes. And if you make mistakes with this, if you add one more zero, and you're working on a big project, for example, a spacecraft, or you're working in a bank, you add one more zero or you add one less zero, you can cost people a lot of money. So in this particular case, if you want to be precise, you are encouraged to use scientific notation like that, so that you know exactly what it is you're doing. With this scientific notation, it's not restricted only to you printing out very large numbers. You can also print out very small numbers. For example, the proton mass, which is what you have here, you can also print out this thing here, so which is 1.6726 e to the power minus 27, and you can print that out like that, and it comes out. So basically, it's very, very convenient if you're using very large numbers. You're dealing with very large numbers. If you're dealing with very small numbers, it's very, very convenient that you use scientific notation. Here, you've got electron mass. You can print that out, and that's what you get. So, yes. Yes.
For very small numbers, I think the output is also indicating it's in the scientific notation.
Yeah.
When you look at the other number, which is
So,
mass, why do you have zeros instead of the output being zero?
Because the number is not very big enough. So automatically, if the number becomes very big, it will quickly change to automatically to decide to display the number in scientific notation.
So what do I do if I want that output to be in scientific notation and not the way it is written?
Sorry?
If I want the output for the distance to be in scientific notation, not the way it is coming out, is there a deliberate move out?
Yes. There's a deliberate move we can do that, but that's for later now.
Okay.
Yes. Okay. So apart from printing numbers, you can also print strings, which is basically text. Now, when you're printing text, you have to enclose your text in double quotation marks or single quotation marks, and these quotation marks need to match. If there's a mismatch in the quotations, then there's going to be a problem. So for example here, if I want to print the text hello world, I'll say print, then I do my hello world in matching double quotation marks, and I do a print, run a print, I get that. If I want to do the same thing with single quotation marks, I'll say print hello world, and that's what I get. If there's a mismatch in the quotation marks, like in this particular case, I start out with the single quotation marks, I end my text with a double quotation marks, and I try to print this. Then Python brings out the red pen, tells you there's something wrong here. And as far as it can try to figure out what the rules are, it will try to at least tell you to say there's something wrong with this. And apart from just underlining, it will try to point here. You can see this caret here. It will try to point, say, I think the problem is somewhere here. So the first thing you notice about Python is that Python is very, very unforgiving. It will always bring out the red pen. You make a mistake about the language, how it works, it brings out the red pen. But apart from bringing the red pen, it will also try to tell you what kind of error you have committed and try to figure out if it can figure out an explanation of what is it you're doing wrong. So in this particular case, apart from pointing out where the error can be, you can see there is this bit here, it says syntax error. Syntax basically refers to the structure of the language, how things are combined, and it tries to offer an explanation of what it thinks the problem is. In this particular case, it says EOL, end of line, while scanning literal. Basically, it didn't find the end of the string. I started out a string, but it didn't find where the string ends because of this mismatch there. So basically, you can do that. If I do the same thing, I start out with double quotation marks, I end with a single quotation marks. Yes?
Yes, sorry, just to take a little bit
Okay.
Probably missed when you introduced this. What interface are you using?
We are using something called Google Collaborator.
Oh,
It's a platform called Google Collaborator. So basically, Google offers us Python computing, a Python computer with, in this particular case, you've got 12 GB RAM and about 100 gigabytes disk space. A virtual computer, yes.
is that what you expect nicely?
Yeah. It executes things nicely. So basically, you have got a Jupyter notebook, but Google decided to build their own Jupyter notebook, web-based Jupyter notebook, which you can use for Python things. Or everything you need about, yes?
Can this same Python work on a phone? Like, since you have a Google account?
Yes. You can use, yes, it will work. As long as you've got a Google account, your phone has got Google Drive, you put the file there, then you can open it with this bit, then your phone is going to figure out what is it you need to use it. So it will go to this particular platform.
So initially you need a hub for the same.
You need a what?
Chrome. I mean, is this Google Column for like a hub? Or you just
No, you don't need an app. The only thing you need is a web browser. Yeah.
And then when preparing this one, you just go to Jupyter.
You can even use the same Google Colab, because the Google Colab itself, as you can see, if I click here, right, there is some options here. This is a cell. I can move it up, down. I can, what they say there? Link to a cell. I can add a comment. The bit of adding a comment, this is where now the collaboration comes in. If you are looking at what your friend has done, you can leave comments, say probably this one, you can do this like this. You can actually collaborate with someone while you're building your code, as long as you have shared that particular thing with them. Here, this is for editing. Then this is, you can delete. Then there's other things you can do. For example, you can copy a cell and like that. So in this particular case, if I want to edit, for example, I click on this pencil, and you can see how I wrote the things. Then something else comes up here, for example. That is for here, this is for boldface, this is for italics, this is for stuff like that. So there's things you can actually do. It's like basically you have a small Microsoft Word to yourself.
Word processing.
Yeah, a word processor. Yes, a very, very small, simple word processor. And a very, very small code executor. So you choose to have a word processor thing where you type your things, your instructions, then in the other bit where you put your Python code.
Okay, just another question. There are two things there. As you write that
Mhm.
string for string,
Mhm.
and the lower,
So this bit is where I'm writing,
okay?
and this bit is what I'm writing looks like. How it looks like. So the output of what I'm writing. So I'm doing this, then it comes out this way. So me typing, then the output of what I'm typing. So basically what you're doing this side is basically some kind of HTML language thing.
You want to put those stars.
No, they just this star here matches that one. You can see it shows you the image.
It's for board, eh?
Yeah, it's for board. Me trying to board, and yeah, the stars are for board. But you can also do the same thing by just clicking here. You select a word, for example, this one. Or let me select there. Then I click on board there. Then it does that. Then you can see the output this side, the result. So basically the only thing you really need to do, you just need to type. Then you click on board, italics, and all these things which you want to do. Yeah, if you want some numbered list there, if you want to indent, if you want to, for example, create a list, you can do that. Like it's simply a simple, most basic word processor you have for you to do your things. Yeah. Okay. Any other question? All right. I think we've got. I need someone.
Can I also ask?
Yes.
I'm trying to really get a hang of how this Python works. Because I'm seeing some similarities with R.
Sorry.
So maybe you can. I'm saying I'm seeing some similarities with how R programming is.
Oh, how R programming works? Yeah.
Yeah,
Yeah, it should be able to work.
Information,
Yeah, it should be able to work.
information that maybe other people have access to it.
Sorry?
I'm saying you were saying the people collaborator.
Yes.
Does anyone have access to it? So if I decided, say, to work with personal information, how is my data secured if I wanted to work with it?
You store your data on your Google Drive.
Okay.
Yeah, because I'm running this thing from the file I'm using for running this thing, it's on Google Drive. So you store your data there on your Google Drive.
So as long as I'm working online, everything that I'm working on can only be accessed by me.
Yeah, you access it online using your computer from anywhere.
Okay.
Yes.
No, all right.
Okay, thank you very much. So if I do a print here, as you can see again, the red pen comes out there. Then there's booleans. Python supports true or false values. So in this particular case, the actual value true, which is basically is written out like that with a capital T. So if I say print true, it prints out true there. Then you also print false. It does that. So basically, if you want to do some things having to do with logic, which is what computers use, then you can also do that. Of interest to us, of course, is mathematics. If you want to do addition, you use the plus sign. You can simply say print 7 plus 9. So basically what you're going to get in this particular case is the result of this particular addition. You get your 16. You can even put some spaces in between the numbers and the operator so that you can increase a bit of readability. It won't affect the result. The result will still come out the same. You get 16. If you want to do subtraction, you use a minus sign. In this particular case, 20 minus 8 and 8 minus 20. If you do a print of that, you get your 12, you get your minus 12. If you want to do multiplication, you use the star or the asterisk, basically 20 times 8 or 8 times 20, whichever bits you figure out, Python will figure out the answer for you, which is 160. Then of course, you can also, it understands this whole thing of associativity, so you can do some calculation in different orders, but in this particular case, since I'm using the same numbers, multiplying them in different ways, I still get the same product, which in this particular case is 18. You can also do division in this particular case. For division, you use a backslash, you say 20 divided by 5 or 5 divided by 20. You do that. In this particular case, you get your 4.0 and your 0.25. So when you're doing division, your result will always be presented as a number with a decimal point in this particular case. If you do not want, if you want to carry out what's referred to as integer division, where you divide into a particular number, then you throw away the remainder. You just want to keep the whole bit, then you use two backslashes in this particular case. So if for 20 divide by 7, if you're doing integer division in this particular case, what you're going to get is you're going to get 2. What's left out is basically discarded in this particular case. If you want to
Sorry, let me just ask there.
Yes.
So, just help us maybe to do the same two numbers on top, but do them with double backslashes.
Here?
Yes, so that we
Okay.
see how the results come out.
So print 20 divided by 7.
Double.
No, I want to show how first when you do it
Oh,
normally.
Since you have it
Yes.
on the other-
So when you do it normally, this is what you get. When you divide 20 divided by 7. But when you do integer division, you only get the 2. This bit after the decimal point is thrown away.
So
Oh.
literally getting the flow of the value,
Hmm?
getting the flow.
Yeah, kind of like you're getting the flow. No, it literally throws away. It doesn't matter whether it's a floor or ceiling. It just throws away the fractional part.
Not necessarily rounding.
It's not rounding
No,
off.
it's not. It's getting
It's just
the flow.
chopping.
So if
It's just chopping anything
flow,
after the 0 out.
but-
It's not rounding off. It's not doing anything. It's just chopping.
Okay, that's
No,
what I wanted
that
to-
is what, yeah, that is what I was asking. Because
There's other things-
matrix is the operator,
Yes.
which shows as the flow.
Yes,
Whether
we
you
also
are-
have. It's also there. It's also there in Python. Yes, yeah.
Okay.
There's a function called flow. There's a function called ceiling. Ceiling. Yes,
Ceiling
yes.
and flow.
That is because Python is based on C. So most of the functions which work with C from the C mathematics library, they are also available in Python, since the creator of Python based it on C. For example, print, if you are a C programmer, is familiar to you because that's the same print you use in C. Yes, so basically, that's basically how things come about. If you want to raise a number to a power, for example, 2 to the power 5, you have to use 2 asterisks, in this particular case, 2 to the power 5. If I do that, I'm going to get 32. You can also raise a number to a very, very small number, in this particular case, 25 to the power 0.5. We know that this is basically equivalent to a square root of 25, and I'm going to get my 5. If I want a remainder of a particular operation, then I use the percent sign. So basically, in this particular case, if we recall, we are doing this bit here, 20 divided by 7. If I change this to not to 6, let me change this to 7. So what we're going to get in this particular case, in the first case, is basically the remainder of our operation. 20 into 7 goes 2 times, that's 14. Then 14 minus 20, that's 6, and that's the 6 which you have there. So basically, that gives you a remainder. For 10, remainder divided by 3, the remainder in this particular case is 1. That's what you have there. If you decide to do the remainder operation for a small number and a big number, basically, it will always give you the small number. The remainder of is dividing a small number by a big number is the small number in front. So basically, this operation in this particular case is not very useful to do that. You can use parentheses to show enforce order, but also to increase readability of your Python thing. So,
just before we move on to that, so what happens if you put a double slash on 3 divided by 10? Do you get a 0?
So let's see. So print 3 double slash 10. You should get 0. Does it? Yeah, get a 0.
That's wrong.
No, it comes after the 0, after the decimal point. It's just chops. It's just chops. Yeah, it's just chops. Yeah. So basically,
Okay, so the answer is supposed to be 0.3.
0.33. So anything after the 0, after the decimal point, it throws away. So you just remain with the bit before the 0.
So it's not a division.
It's integer division. Simply integer division. Yeah. So if you want to do proper division, then you have to use a single
My
slash.
suspicion is it's useful somewhere.
Yeah, it's useful somewhere.
Especially when you're programming, you want to carry out some manipulations where you want to chop. You don't want the whatever is after the decimal point to appear.
Okay, so here we have something interesting here. We have got 1 plus 2 times 3, which of course we can figure out, say, fine, the multiplication is done first, then the addition is done later. That's okay. But you can also use parentheses to clearly enforce, say, readability. It's not changing anything, the result is the same. But for readability purposes only, it's like, fine, we'll start with the 2 times 3, then later on the addition is going to be done. So you get the same result there. But you can also do the other bit, where if you want to do the addition first, you need to force the code now to say, I want the addition done first, then the other bit later. So in this particular case, you start with whatever is in the parentheses, and then you do the addition. So in this particular case, you're going to get 9 instead of 7. So you can use parentheses for this particular bit to change the order in which a calculation is being done, or to simply make your code more readable without changing anything really. Okay. Now, next bit is comments. Now, comments are very important because you want to document your code. Because if you look at your code maybe in a year's time, or someone is looking at your code, you want to leave yourself some notes on what you're doing. We make comments in Python using the hash, like in other languages also C. So here basically anything which comes after the hash is ignored. It's not treated as Python code, it's simply treated as a comment. So in this particular case, this bit here, this is a comment there, that's a comment. we have got the Python code here, but we start with a comment. Everything after that is ignored. This bit here, where you start with the comment, then you put your Python code after the comment. This is what you refer to as a bad comment. And this bit here, you run your Python code, then you put your comment under. This is basically not really how we make comments. It's a comment, yes, but it's a misleading one, because usually we tend to put comments before the code or on the side. So basically, in all these cases, if you run it, you only see the calculations being done. This one is 3 plus 7, that is 10. The other one, 3 times 7, that is 21. Everything else is not printed out. It's not displayed because it's ignored. It's being treated as comments. So basically, that's how you make yourself nice comments, so that you can leave yourself notes on what is it you're trying to do. How are you thinking? If you're doing your projects, then what are you doing here? If you have to explain to your supervisor what you've been doing, then you can leave some of these comments there in your code. Variables are very, very important when it comes to programming, because we use them for storing values. So in this particular case, Python, when you're creating a variable, the moment you're creating a variable, you need to give it a value. So you're not allowed to create a variable like in other programming languages without giving it a value, hoping that you give it a value later on. The instant you create a variable, you have to give it a value. Naming for variables, basically a variable name can start with a number. You are encouraged to come up with descriptive variable names, meaningful names, and also if your variable name, in your effort to create a descriptive and meaningful variable name, if you come up with a variable which has got a multi-word variable, basically those words can be connected with an underscore. So you can connect the words with an underscore so that you do that it works. So in this particular case, for example, creating a variable pi, then at the instance I'm creating a variable pi, I assign it a value. So basically this is what you have to do. You create a variable, then you give it a value. So this is the process of, this is basically what is referred to as variable assignment or declaration and stuff like that. I'm not specifying what kind of data this particular variable is going to have, because it's not necessary in Python, but there's a way of checking what kind of data a variable has. So that's pi. Now when I print, so you can use your print function to print out variables. If I say print pi, I get the value, not the pi itself. I get the value which has been stored in the pi.
Sorry, just a matter of check. So for Python, is pi an inbuilt
No, it's just a variable name I've chosen. But this.
What I mean is, yes, here you have chosen it like that, but doesn't it exist in the system already?
It might exist in some library somewhere, but that particular library right now is not being used. So it's not in our scope of the computer. There's something called scoping. Yes.
What Fred is asking is, can you create that variable pi and call it pi?
Yes, you can.
Yes, you can. And also what you say is, does that make pi? Yes, it does. If you go to
There's also something called math. There's a math library.
Okay, because why I'm asking this is, as Professor has said, you can give it a value of 5. And my worry is, will there be a conflict at some point when you are doing your program?
No, it won't. Okay. Because of the scope. There's this idea of, yes.
So just a bit that pi directly does not exist, we can call it as, you need to summon other functions like the same math or number.
So for us to access pi, we need to look at the library, summon some library somewhere which has got the value of pi itself.
Yeah, this is what I'm saying. At some point, don't you risk a chance of running into a conflict?
Usually what happens is that, typing very large values like this is tedious and it's cumbersome. So basically what you do is you simply summon some library somewhere, then from that library you get the value of pi.
Just help him that if you want to use that, for example, math, you want to use the pi, you're going to call the pi, you say pi dot, you say math, then you will bring that pi. But if you write it pi just like that, you always say okay. So there won't be a conflict.
Same. So that's pi. Then there's radius. the idea of creating descriptive variables, meaningful variables, instead of just saying ara, it's better if you say radius so that you know what kind of variable this particular thing is. Because ara can be anything. Ara can be a coefficient of what is that thing? Correlation or something like that. So ara could literally be anything. Yeah. So basically, just a little bit of effort. You choose a name for a particular variable, then you put it there, then you can print that particular variable, you get that. Now, based on that, I can work out the area of a circle using this formula. A is equals to pi r squared. So how I'm going to do that? Using the mathematics you have learned so far. So I'll say print pi times radius, then radius to the power, raised to the power 2. When I do this, I'm going to get the result of that particular calculation there, which is basically the area of that particular bit of circle. I can also decide to store this particular value in a variable, since it's area. So I can create a variable area here. I can create a new variable area. Then I will assign it the result of the calculation. So instead of printing out, I do this calculation, get the value, straight away store the value in this particular variable area like that. Then I print out the area. I get the same thing. So this is basically the power of variables. They allow you to store values. They also allow you to do calculations more efficiently and store the results of those calculations somewhere else so that you can later on access them. Since it's a variable, of course, it means that you can change the value of that particular variable. For example, radius at 10. Now I change the value of radius to 5.5. Then I repeat the calculation of area in this particular case. And if I print out the area comes out to be different in this particular case. So that's variables. They have the values they hold. You can change them as you go by. With the bit of creating variables which are meaningful, for example, we looked at the electron mass. Instead of just saying ME, as you might be tempted to do when you, because that's how you do your physics calculation on paper, it is better if you actually write out the name itself. Electron, since it's a multi-word name, electron underscore mass. So basically, you've got a nice variable for electron mass so that any person who looks at this, they know what they're expecting to see. They're expecting, if they're going to use this variable, they're expecting to see the value of an electron if they know their physics bit there. Then I can print that. Okay, there's also, you can also have variables with multiple weights like sun-earth distance in this particular case, which is what you had there. So sun-earth distance, and you can notice after the value there, I added a tiny bit there. I added a small comment there, say in kgs, trying to give myself a note to say this mass of an electron is in units of kgs. So you can do that. If you've got mass of an electron, which is atomic mass units, you can also give yourself a comment, say this mass, electron mass, I'm trying to use in this calculation is in this particular units. Again here, sun-earth distance, I assign it a value there, then I also say this is in meters. And I can do a print. Okay, so that's nice that we can do that. More importantly is when you're doing a programming thing, you need to ask for information from a person. Otherwise, if people can't input information in your program, probably its application is going to be very limited. Now, how do you get this information from a person? Now, to do that, there is a function called input, which you use. So input allows you, it does two things. It gives you a way of displaying what kind of information you want to collect. It also collects the information as you are typing on the keyboard. Then once you collect that information, you can store it in a variable straight away. So three things. It displays information you're asking for. It allows the person to type the information. They press enter. That information is collected. It stores it in a particular variable. So what do I want to do in this particular case? So I want to ask a person. In this case, I'm asking myself to enter my first name. So basically, this is what is going to be displayed. This is what the person who is using the thing is going to see. So it will say enter your first name. They need to open up a space where I'm supposed to type the first name. I type that first name. Then once I type that first name, on this particular end, I've got a variable. Whatever I've typed after I press enter is going to be stored in that particular variable. So if I run this is what you see. It says enter your first name. And you can see there's some 3 dots there, meaning that this particular code is running and it's waiting for me to type something. So what do? I click inside here, then I type my name, gift. If I'm satisfied that that's how my name looks like, I press enter. When I press enter, it finishes running. Now, if I type, I print out first name, I get the value I typed. So basically, this is a very small, neat way of asking a person for a particular piece of information, allowing them to enter the information, get the information, put it in a variable, then use that information later. Here, I also want the surname. So I ask myself, what is my surname? I type Stone, I press enter. Then I do a print of surname, and that's what I get. I ask myself, enter your age. Then whatever it is I'm going to enter, I'll store it in the variable age. Okay, 36. I press enter. Then I print out 8. So with what we have done so far, we can put all these things together. Remember, print can print out multiple values, not just numbers, different types of values. So now I can say, hello, this is a value, that's a string. Then I print out, since I'm printing out multiple values, I put a comma, so I separate my values, comma, first name, so that should print out my first name, then comma, surname, then comma, dot. Then you are, comma, age, comma, years old. Then basically if I do this, I run this is what I get. So it says, hello gift Stoner, you are 36 years old. So basically you can use print not just to print out a certain type of data, but a combination of different data, as long as you have separated those things. A very simple way of doing things, as long as you have separated those data values. So basically all these things are being looked at as values. Anything after the comma is being looked at as a particular value, which print just goes out and spits out. If there's a variable, instead of the variable itself, you get the value which has been stored in that particular variable. So how do I know what kind of value is in the variable? That's where this particular function called type comes in. So I say type, then I give it the name of the variable, pi. So it says I've got a float, basically, which is a number with a decimal point. I say type, radius, in this particular case, radius is also a float. Type area is a float. Type first name is a string. I got first name using the input function, so it's a string, and of course it's a string. There's letters. Surname, type surname is a string, but something interesting you're going to see. I said input age. I entered a number which is 36, but if you give this particular function age, it tells you that age is a string. The reason why this is the case is because everything input gets, it slaps quotation marks on it. It has got no way of figuring out, say, this is a number, this is this. No, it just goes, collects, then puts quotation marks on it. It's much simpler way. It's a simpler way that way. So if you collect numbers, values like this, for example, you have a program, you're collecting, for example, Ms. Kazia here, some interest rate calculation she's trying to do with Python. She enters some rate or some principal amount. You're asking a person, you've created a program, you ask a person, enter this, how much is the principal? They enter that principal using, you collect this principal using the input function. What is going to be collected is not the number itself, but it's a string. But since she wants to do calculation with this number, there has to be a way to change these strings into numbers. Actual numbers she can actually use. And there's a way to do that. And that's what brings us to this particular bit here called data conversion. So we go back to the radius. Remember we set the radius as a number, but if you ask someone to enter the radius of a particular circle whose area they're trying to work out using the input function, the radius they're going to collect is going to be a string. Since it's a string, it can't be used for a calculation. So there has to be a way you can change that particular radius from being a string into something else. So in this particular, enter the radius. So you can say the radius is how much? What radius should we use?
10.
We already used 10. 59. It's too big here. Get fine, 59. Alright, 59.1. Let's say 59.7. So we do that, then I press enter. Then I check what type of value is stored in radius. If I check, I find out that it's string. Because it's a string, I typed a number, but it has been stored as a string. It's not possible for me to directly use this. If I try to do that, use it in a calculation here, area, pi times radius to the power 2. If I try to do that, an error happens. Python brings out the red pen. Now, it's going to, if you look at the calculation, what it says here, it's even points, there's a problem with this line here. Can't really figure out, but what it's seeing here, it says the type error. So basically, what it's trying to say here, it says this bit here, for power, this exponential calculation I'm trying to do, or the power, I'm trying to raise a string to a particular power, which is not what happens, because I can only raise things to power, I can only raise numbers to powers, but in this particular case I'm trying to raise the string to power, and that's why the calculation fails. So how do we overcome this particular problem? Well, there's a function called float, which changes, which is going to change our string radius into an actual number which we can use, and that's basically what we do here. So we say float, so we give this particular function radius, we give it a variable radius, then it's going to change this radius from it. It's going to make a copy of that thing, change it into a number, then store it back into radius. So when it does that, good, no complaints. Now if we check for the type, now we've got a float. So that particular function does that. With that bit, now we can actually do our calculation now of area, and we can print out what the area is. There. So that basically area. So basically that's how you go about doing that. Same thing with our age. Our age, as you can see, is a string. If you don't want your age as a string, but you want it as an integer, in this particular case, so you can use a function called int. So you give your variable age to this function int, which is going to make a copy of whatever the variable is holding, then change that into an integer and store it back into that particular variable, so that you overwrite the string which was stored there, so that you end up having an integer. And if you check out the what you have now that you have an int, the same thing with this bit here. Remember these Boolean values? The ones we had true. So these are Booleans, right? True or false. But if you want to see their integer equivalents, so you can also give these particular things, this particular function int, and if you run this, you see that the computer sees true as 1, and your computer sees your false value as a 0. So basically, the int function, these tiny functions, which are all over, I have not done anything. Remember, you haven't seen me creating a function called int, float, and these things are already there. It's literally basically you opening up this box you have and choosing what is it you want to use. The issue with Python is you knowing what's available to you and using it to your ends. That's basically where the issue is. And that's what this series of lectures is trying to solve. This particular, making you aware of what you can do, what's available for you, where you can find it, how you can use it. Here I have, I set the current year, we're in 2022, so I set it to that, an integer. Then I print it out. Then I check the type. It's int. But then I want to change this particular, I want to slap some quotation marks on my integer. So what do? I use a function called string, str. So with this function called string, I give it a variable, so it's going to make a copy of whatever value is there, then it's going to slap quotation marks on it, then store it back into this current year. Then now if I check the type, now it's a string. Same for pi. I have pi. If I check pi, then if I want pi as a string, the value of pi as a string, I give it pi, the variable pi to string, I store it back into pi. Then I check the data type. There. There is also a function called bool, for boolean short. This one basically changes non-zero values into true. Anything which is non-zero into true. It might be positive, negative. As long as it's not zero, it will be changed into a true. Changes zeros into false. So basically here, if I give bool 100, we change the 100 changes to true. I give bool 1, changes into true. If I give the function bool 0, changes to false. If I give it a negative value, -5, changes into true. If I give it -5 and 5, changes into true. So anything which is non-zero is converted into a true value, and a 0 is converted into a false. So basically, that is a neat function there. If they are doing some things, then you have to do that in that bit here. So with this, we are going to create our simple program, which actually uses what we have done, our area thing, calculation. So in this particular case, I start out with a comment.
Okay, so maybe Mr. Sichone, we are almost there.
Yeah, this is the last part.
Okay.
Yeah, just have to explain. It's just everything. So here is the name of our program. Now, if you are creating a Python program, it has to end with a .py, the name of the function that you do that. Then this is a bit of a comment trying to explain what the function does. Then I set the value pi to this. Then I ask for the radius. Then since the radius is going to be stored as a string, then I convert the radius into a number float. Then I do the calculation of pi. Then I print out, say the area of a circle is this much. So if I run this bit here, if I run this, okay, just a minute. If I run this, so there, then I can say, okay, fine, radius is what? 7.8. I press enter. Then it does a calculation and it gives us what it is. This, so basically, that's your, you can put all your things, all your codes in a tiny cell. So we have come to the end of our introductory Python lectures. Questions? Comments?
Well, we are at 11 hours. I know some people are not going somewhere, but I think maybe allow us to proceed nicely next week, since we are continuing with the same Python lectures.
Okay.
So next week we can start where we ended.
No, this one has come to the end. This bit has ended.
Mm-hmm.
Yeah.
How do I access this?
This, which one?
Lecture notes.
The notes we're using?
Yes.
Yeah, if you have a flash, I can give it to you. Then you put it in your Google Drive.
Maybe the best is people who are interested can give you their email addresses.
Yeah, I think people,
you
you can give me your email addresses, then I can send you the attachment so that you play with it and you study it, so that because next week you'll be continuing this similar bit, you can refresh and continue from there.
Yeah, so both those online and us, we can give you the email addresses.
For those in the department, we're going to create a folder on the department computer where we'll just put these things. So you can just go and get them from there. The video recording, because we have been recording this thing, the video recording and the file itself, we're just going to put them there. So they'll be just accumulating there as we do these things during the course of the year. So we would encourage people not to delete the folder we're going to create there, because that's where I'm going to be dumping these things. And also, yeah, basically.
Have you been recording this?
Yes,
He was recording.
Oh, you are recording?
I'm recording myself. There is this bit here,
Okay.
this tiny thing.
When you say it's going to be, they're always there.
Yes, the recording and also the file itself, because the recording just allows you to watch. But
So
if you
for
actually
us
want
in
to,
the department, he will put these things on the departmental computer, but maybe for you, you can give him your email or a flash drive. That's what he said.
and also for other people, I think the recording, I tend to post my things on YouTube. So you can simply search for my name on YouTube, then you will find this same video there also. So instead of you following me around, you simply do a search on YouTube search, then you'll find the same video there. because I'll put it there by the end of what you're doing here. By the end of the day, it should be there. Yeah.
Okay, thank you. So we continue next week. Have a nice day. Sure.
Okay.
So I don't know if the new class coming, but we can briefly deliberate on the Munari trip. Yeah.
Python is